Well, hello everyone, and welcome back to my shop. Alright, welcome back. Today we're going to get back on this 75 Corvette Stingray with the L48 small block Chevy 350 engine, and more specifically we're going to get back on that high energy ignition module, commonly referred to as the HEI, and the modification I did to it the other day. Let's get back on that and I'll explain some more to you. Alright, now what I'm going to do is I'm going to modify the way this distributor advances from idle up through its RPM range. Right now it's set up pretty close to stock. It utilizes no vacuum at idle, and there's no mechanical advance at idle. And I've got a preset initial timing of 8 degrees before top dead center. Now once you start, this engine starts accelerating, it'll introduce ported vacuum to the distributor, and it'll start giving advance then, once you start putting a load on it. And at some point, which I've not measured yet, it will start engaging the mechanical advance. So you'll have initial, vacuum, and mechanical advance applied once the engine starts spinning up. That is how the manufacturer wants this engine to be set up. Well, there's a train of thought going out that back in the old days, previous to the 60s, that engines would get full vacuum advance, in other words, full manifold vacuum advance at idle, and as the engine would accelerate, it would introduce mechanical advance. The advantages of this would be that engineers say that at idle the fuel air mixture is really lean, and lean fuel air mixture takes a long time to burn, so your efficiency is not good, and you're losing a lot of your heat that you need to drive that piston down actually going out the exhaust. So by giving it more advance at idle, it gives that lean mixture more time to burn, and it'll burn more completely and generate more power. So that's the key. I did a lot of reading, and two authors jump out real quick on this. There's a lot more, but two main ones: Lars Grimsrud, I might be mispronouncing that name, but I think that's how it's pronounced, and John Hinckley. And both of them are engineers. That Lars being a former GM engineer. They indicate that ported vacuum was introduced just to meet smog and emission control, and that if you want the best out of your engine, performance-wise, cooling-wise, mile per gallon-wise, just a more efficient engine, you need to run full manifold vacuum to the distributor at idle, okay, which is against everything that I was taught. So I researched and read a lot of testimonials, and to a T, they all claim this is right. Now I'm going to throw a little. Now they say that they didn't. The manufacturers didn't start introducing this ported vacuum until the 60s. Well, I'm going to throw a curve at that. my 1949 Chevrolet pickup over there with the 216 engine, with the Rochester single barrel, which both these were stock now, okay? It used ported vacuum, and it was easy to tell that it was ported vacuum, because back in the day on that old 216 and 235 engines, instead of having a plate that turned when vacuum advance was applied inside the distributor, those old engines, the entire distributor rotated. So you couldn't miss when vacuum advance was being applied to that, because the vacuum canister pulls the distributor over. And of course, I've changed my distributor now on the 235 that I rebuilt and put in the Chevy, so I can't show you. I have the old engine sitting over here. I may do a still picture just to kind of point it out. But anyway, so in 49, they used ported vacuum on that 216 and the 235 engines. That's what I know. So there's a little bit of curve in what they're saying, but the testimonials say try it. So I've got a good benchmark now. I know that if I set my initial timing to 8 degrees before top dead center, that I am fairly happy with the performance I'm getting out of this engine. It starts good, good low speed pull, good high speed pull. It'll go 100 plus, no problem, and without missing. I just get that slight little miss there between 45 and 60. It's just a little bit. And I still don't think it's the carburetor yet. So I'm going to change my timing. Long story short, I am changing this timing from ported to direct manifold vacuum and reset it up, and let's see how it does. So, with all that said, stay tuned and let's get it done. All right, there's some settings I already know. There's procedures that are spelled out in the documents I've downloaded, and I'm going to kind of skip around a bunch of them because I kind of got an idea of what I'm dealing with. So I'm going to remove the air cleaner, give this thing a start, start getting it warmed up so we can do our change. That's going to take it a couple minutes to warm up. We've got pouring rain, we've got thunderstorms, but the temperature's not bad, so I may have to go start thinking about a summertime choke setting, but we'll worry about that later. So what I'm going to do now is I'm going to hook up my vacuum gauge to what I think is a constant vacuum source. Enough. But I'm going to go ahead and move the distributor ported vacuum up to this constant vacuum source now, and we should see the RPM raise considerably. I can get the distributor vacuum off. See that? Racing about 200 RPM. To drop the idle speed. Now we're going to check the timing. Now they say that this initial timing doesn't really matter, but I really think that's too high. What I need to do now is see how much total vacuum I'm getting, and I may have to back that initial down. All right? So let's see. I think my timing light's messing up. I'll be right back. All right, I'm getting too much vacuum advance at idle, and so what I'm going to do is limit it. Now this is not an adjustable vacuum can, but I'm going to show you how far it throws. Okay, watch the arm there. All right, you see it goes all the way. All right, and I'm only at 10 inches of vacuum to get it to that point. All right, release it. All right, go back, and there's max throw at about 12, and I'm getting almost 20 now. So what I want to do to limit that is I discovered something that that I think I can use. Now, they have kits, the metal kits that you can actually put a metal bar across here to stop it. But I read somewhere else where they said you could take a rubber bushing in there and it will keep it from the throw going all the way. Well, I don't have a rubber bushing, but I've got this plastic thick bushing that came with the HAI kit, and it fits perfect over that rod there. So what I'm going to do, and I've had to cut it down, so as a matter of fact, here, let me show you. The kit came with black, red, and blue, with black being the thickest. Then you had red, and then being thick, a little less thick, and then blue being the thinnest. So I've decided I'm going to go with the black, and you can see how much I had to cut it down. So that was kind of a pain to cut it down, but we got it cut down. We're going to put him on here. There's just enough flexibility to bend that rod out, swing it over, and get that on. It fits. Well, I said perfectly. There you go. And there you go. Now, it doesn't go all the way to the back, and it's still not touching it, so it's not keeping it from going all the way. Now, hook my Mighty Vac back up, and let's watch. You can see now there's less vacuum now to pull it to that, but that's a stop. It's not going any further. And it said in the paperwork 0.86, I think, to 0.112, somewhere around in there, which is like, I don't know, between a 32nd and a 16th of an inch. I think I've got that there. So we're going to hook it up. We're going to run with this and see what we get. Anyway. I didn't show taking it off, but I'm showing putting it on. There's only 2 screws. It's actually not hard. It's you gotta do a little finagling to get it in and out, but it's not hard to get in and out. All right. Right. Now I'm going to hook up my Mighty Vac and test it while it's in there. All right. It's not sticking at all. All right. All right. So we're going to see what we get from that. I'll know soon enough if I've swapped them plugs around. Alright. I'm going to hook him up here. My timing light's been acting strange, so I'm going to hook him on number 1 up here and keep him away from that heat down there. Alright, see if it works a little better. Alright, that dropped the idle quite a bit. So let's take him back up. So it's doing definitely limited. Oh, well, no wonder I didn't have the vacuum plugged in. Come on, timing light. That's better. We're about at 20 now. So that dropped at a good 9 degrees. Now let's see what my max is. If my timing light will stay working. Like it's about 51. I haven't adjusted my total timing at all. I have not spun the distributor. So basically all I'm doing is giving it more advance now, vacuum advance at idle, and possibly at a steady cruise. I should not have affected my maximum. Well, if anything, I should have dropped it down some because of that limiter I put in there. So, may end up advancing this some more. If I can get my timing light to work right. Well, now it's idling good. Well, it was. Test. It's dry enough. So far, low speed performance has definitely improved. We're headed to the interstate, so we'll see what happens there. So hang on. Alright, I always seem to get out here in traffic. We can run a little bit. Let's see what we got. But I got up to 90, no missing. That's a good thing. It's just, I don't know what it is. Karma or what. There's nothing that's going to let me get out here and do any running. Anyway, I'm just surprised at all the traffic. Of course, it's not even rush hour yet. Now we're going to try a little acceleration. All right, safely made it back from the test drive, and actually I've done quite a few more test drives and quite a few more measurements. So I'm going to update the settings I'm at now, and this is what I'm going to run with. So anyway, we've got at 800 RPM at idle. Now, when I put this thing in gear, this is the automatic, of course, it'll drop 150 to 200 RPM under a load of the automatic transmission, which puts it at around 600, 650 RPM, and that's what the book specifies is where this should idle in gear. So in order to get that, I'm idling unloaded at about 750 to 800 RPM, and to 810 RPM, somewhere in that range. All right. So with that, we'll just call it 800 RPM. At 800 RPM, I am putting full manifold vacuum to the distributor. All right. And it is giving me at idle 27 degrees before top dead center, which is real close to the 29 I was at that I thought was too high, and I put the limiter in the vacuum advance module to keep it down. So the reason why it's at 27 is because I decided I was going to use the max mechanical advance as my benchmark. So I was going to set that, and then I was going to see where the other settings fell. And of course, I come to this by several road tests. So anyway, this is what I come up with. At max mechanical advance, no vacuum, I'm sitting at around 34 to 35 degrees before top dead center at around 3,000 RPM, which is some of the paperwork says to try to get it in sooner, but I'd have to do lighten those flyweights or make them heavy, one or the other. And those are the OEM flyweights. I did not change them out with the flyweights that came in the Moroso kit because I didn't see anything wrong with the OEM. So I'm staying with the OEMs. All right. Also, I've got the silver lighter springs in the distributor, which allows them to spread out quicker than the OEM. Now you can look at my previous video where I did the springs, and you can see how I came about to the spring setting, which is a whole different topic because I went through a lot of tests on it, but I've settled on the springs. So anyway, I'm at 34 to 35 degrees before top dead center at maximum mechanical advance. Now that's optimum, they say, is 36. I'm running 87 octane pump gas, and I don't want to have to move up to the higher octane, the 93 or whatever, to try to keep the pinging down. So I'm tuning to 87. As we all know, we don't know where gas is going to go with the prices and the availability. So I'm tuning to 87. So that's why I'm at 34 to 35 degrees before top dead center at maximum mechanical advance. What that gives me is 27 degrees before top dead center with full manifold vacuum and idle. Now, I know a lot of you are scratching your head and saying, well, Dave, you were at 12 degrees initial timing before, and that you got valve pinging, and I did. Oddly enough, with this full manifold vacuum, okay, full manifold vacuum, going to that distributor at idle, my initial mechanical idle timing is, believe it or not, 16. All right? And I have no valve ping. I have no indications that I am too advanced for this car to run. So, a real quick overview. All right, so let's get it down. My maximum mechanical only initial valve timing at 800 RPM is 16 degrees before top dead center. With vacuum, full manifold vacuum added, it is 27 degrees before top dead center at 800 RPM. And to repeat, I have no valve ping, I have no indication that I'm running too advanced at idle. So, and I have a theory on that, and I'll touch on that in a minute. My maximum mechanical only advance, which is the benchmark, is what I set to, is 34 to 35 degrees before top dead center at 3,000 RPM. And this brings my total advance, my total mechanical and vacuum advance at 3,000 RPM to 3,200 RPM. It's 50 degrees before top dead center. All right. Now the key that I'm told in everything that I've read is you do not ever want to exceed 52 degrees before top dead center at maximum vacuum and mechanical advance. So I'm at 50. That gives me a couple degrees of buffer, and I'm happy with it. The car, now this 75 L48 was about the least powered, the most underpowered Vette besides the six bangers originally that they ever put in a Corvette Stingray. Okay, so and I think maybe the early 265s may have been a little underpowered to this, but as far as in the modern era with the 350 engine, this is the least powered 350 engine they ever put in one of these Vettes. All right. At these settings, before I could not, from a dead stop, and I nailed it, I could not turn them tires over. They would not lay any rubber down, okay? They will now. I don't do that because tires are too expensive and I don't have the need to lay the rubber down anymore, but at least it'll do it now. All right, no hesitation, starting off, going through the gears, slowing down, going through curves, accelerating out of a curve, no hesitation, no valve ping. Going up a hill in high gear, no valve ping. Now that's at the settings I'm telling you I'm at, which is amazing. Acceleration, great. It's never been, this engine has never been, since I've owned it, as quick as it is now. But I'm telling you, it's kind of anemic though for a 350, but we're working on that. All right, at under 40 mile an hour, and I nail it, it'll drop into passing gear, and it will press me back in the seat a little bit, and it'll accelerate the way I feel it should. All right, for this setup. At above 40, and I nail it, it'll climb fairly fast, faster than it did before, so I'm pretty happy with that for this particular setup. Not because, this being a Vette, I'm really not happy with it, but considering the limitations of this engine, I'm happy with it. Cruising at a steady speed. Before, it jumped around every time I do an adjustment, either on the timing, or the way I apply the timing, it would move a slight miss. At first, I had the slight miss at any cruising speed. Then I had the slight miss at above 80. Then I had the slight miss at above 40, up to 55, 60. Just slight. I mean, you could feel it every now and again. Okay. Totally gone. Totally gone. So, we can let the debates begin on whether or not it is good to have full manifold vacuum on a fairly stock engine. In this case, I am noticing nothing but improvement in all-around performance and operation of this engine. Okay? Now, the long term will tell more. Supposedly, it should run cooler. Now, it's been cold outside when I've done my tests, so I can't, it's naturally going to run cooler, so I can't hardly tell. So I'll know more with the heat days coming up, like today, it's supposed to get up into the mid-70s, so I may take it out then. And it's also supposed to get better mileage. So I've got a full, I've done some idling though, so this may not be a good tank full to tell. but I've been averaging around 14. You know, if it'll get up to around 15 or so, then hey, yeah, that's pretty good. So anyway, do I recommend this? Well, what I'd say is you could try, you know, if you're happy with the way your engine's performing now, get your benchmarks, get your initial timing, get what it is now and write it down. Get your maximum mechanical only, where you got to cap your vacuum, disconnect the vacuum to the distributor and cap it. Get your maximum mechanical advance and write it down. Then connect your vacuum and get your maximum mechanical and vacuum advance and write it down. There's your benchmarks. That way you know you can put it back. Then you can try it yourself. You can just try, you know, on these mid 70s and up vets. There are several manifold vacuum taps on that quadrajet carburetor that are I've just got capped. You had one that would go to the EFE, which is a preheat kind of control that the engine had to try to heat it up faster, okay? And the other went to the EGR control, which also would not allow vacuum advance to go to the distributor until the engine was warmed up. So there's two ports that are just unused that are capped on the front of this that you can use to get full manifold vacuum without having to disconnect anything. So anyway, because you got full on this particular model, you got full manifold vacuum going to the headlight switch setup, because it used vacuum to open and close the headlight doors. You've got full manifold vacuum going back to the modulator valve on the transmission. You got full manifold vacuum going to your brake booster, and you got full manifold vacuum going to the PVC or PCV, and you've got full manifold vacuum going to the charcoal canister, which vents the gas tank. So there's a lot of vacuum. They really went after, back in the day, this is before electronics was introduced, they utilized vacuum to do all the work. So anyway, with all that said, there's still two unused taps you can use if you've capped your EGR and your EFE systems. If you've removed them, you've got them too. If not, well, you can put a T in a constant vacuum in to get that too. So anyway, thought that's a lot of talking, I know, but I thought I'd update, and that's the settings I'm at now, which to me, I can't believe it's running as good as it is at the high settings they're at. So I'm gonna run it like this for a while, and I'll update every now and again if I get anything negative out of this, or if it causes some kind of problem. But at this particular juncture, I've done cold starts, I've run in the cold, I've done interstate runs, I've done back road runs, I've done acceleration before, with passing gear, without passing gear. And I've held cruises at steady speeds at 40, 45, 50, 55, 60, and at above 80 to 85, 85, and a little bit at 90. And just purring like a small block Chevy engine should. But anyway, all that said, that's where we're at. So, I hope everything's going good with you and yours. Everything's going good here. Can't complain. Won't do me no good to complain anyway. I just take care of the business. Of course I will complain some. We can't help it, can we? Huh? So, have a good one, and I hope to see you around on the next one. See you.